Now let's talk about a slightly more advanced concept, the concept of conditional probabilities. And this is what we're going to use a lot today. So it's a good thing to review and a good thing to really keep in mind and understand. Now, a sentence here might say, the probability that a review that has 3 awesomes in it and 1 awful is positive is 0.9. So a mouthful, what does that mean? Let's interpret it by looking at a little bit of data. So let's say that I have my data set and I'm just highlighting here awesomes and awfuls. And in fact, I'm highlighting the sentences that had 3 awesomes and 1 awful. So if I go and mark all of those and I just look at those rows where the condition, this part up here is called the condition, and that's why it's called conditional probability, 3 awesomes and 1 awful. So out of the rows that have 3 awesomes and 1 awful, I expect on average that 90% of those are going to be positive reviews. And that makes sense. If you have 3 awesomes and 1 awful, very likely to be a positive review. So this is how we interpret it. I expect 90% of the rows are going to have a +1 in them. See, there's one here that has a -1, but in general, we have a lot of +1s. Now, we can again interpret the conditional probabilities in terms of degrees of beliefs about how we feel about the reviews. But this is not how we feel about reviews in general. How do we feel about reviews specifically? So, for example, if I have a condition xi, an input xi that says, oh, the sushi was delicious, what's the probability that the review is positive in that condition? So here we have the probability of the output being positive, and we use the word given. This little bar here means given or conditioned on the input, which in our case was, oh, the sushi was delicious. It was delicious. And so if that conditional probability has value, I wrote on top of my own labels, but I hope it makes sense. That's the output label, input sentence, and these are all the parts of the probability. Now, if I say that that output has probability 1, given this input, all sushi was delicious, then that means that I'm still absolutely sure that the review, all the sushi was delicious, is a positive review. I feel pretty good about that. So we're going to denote it by probability of y equals +1 given xi. This is our shorthand here notation, is equal to 1. What does that imply, by the way? Is it the probability that y is equal to -1 given xi is 1 minus the probability of y equals +1 given xi, which in our case would be 0. So what does that mean? That if this, the probability that this is a positive review, given that the input sentence is all sushi was delicious is 1, then the probability that it's a negative review is 0. Similarly, if we output the probability y equals +1 is 0, that means that I'm absolutely sure that the review, all the sushi was delicious, is negative. I actually am not sure of that. But in that case, it would mean that. And that means that the probability of y equals +1, given the input xi, is 0. And that would imply that we believe that it's a negative review with given this input with probability 1. You could be somewhere in between. So for example, let's say that's the probability of y equals +1 given the input all the sushi is delicious is 0.5. That is that I'm not sure if that review is positive or negative. So what I'm saying is that the probability of y is +1 given xi is the same as the probability of y equals -1 given xi, which is 0.5. So I would believe that it's 50-50. In reality, for this input, I believe we'll be somewhere around here. So the probability will be very, very high that is a positive review. So let's talk about a few important properties of conditional probabilities. First, if we have two classes, conditional probabilities are always between 0 and 1. So the probability that y is equal to plus 1 given xi is somewhere between 0 and 1. Similarly, the probability that y is minus 1 given xi is somewhere between 0 and 1. Now, interestingly and importantly, the conditional probabilities add up to 1 over y, over the left side of the conditional. So the probability that y is equal to plus 1 given xi, if I add it with the probability that y is equal to minus 1 given xi, that adds up to 1. However, but it's not true if you sum the right side, if you sum over the sentences or over xi or anything like that. So for example, if you said sum over all possible sentences of the probability of y equals plus 1 given x, that is not required to be 1. Or for example, let's say that you summed over all the data points, and you might have n of them, of the probability of y equals plus 1 given xi. Again, that is not 1, not required to be 1. So they add up to 1 on the left side, on the over y's. Now we talked about the binary case, let's talk about multiple classes. So in this case, same example as before, so y can be dog, but now we conditioned it on the image xi, or y can be cat with a particular image xi as input, or y can be bird with a particular input xi, and we have that these are between 0 or 1. And that's our input-output here. Now, similarly, with multiple classes, we have the probabilities add up to 1 over if you sum over possible values of y's. So we have the probability that y is equal to dog for this particular image xi, and you add that the probability that y is equal to cat for this particular image xi, and you add the probability that y is equal to bird for this particular xi, and you add all those together and you get 1. And here you go. Now we've covered very quickly a summary of the key properties of probabilities and conditional probabilities, and we're going to use them at a high level throughout this particular module and throughout the specialization.